This is the Edexcel Extended Math Certificate Level 2 Paper 1 from the Specimen papers, and this paper is a non-calculator paper. Question number 1, Part A. Use the factor theorem to show that x subtract 2 is a factor of 2x cubed plus 9x squared subtract 11x subtract 30. To begin with, let us let f of x equal 2x cubed plus 9x squared subtract 11x subtract 30. If we wish to use the factor theorem to show that x subtract 2 is a factor of this cubic, then we have x subtract 2 equals 0, meaning x is equal to 2. And knowing that x is equal to 2, we will substitute in 2 into f of x. And if we get 0, then indeed x subtract 2 is a factor of f of x. So f of 2, that's equal to 2 multiplied by 2 cubed plus 9 multiplied by 2 squared subtract 11 multiplied by 2 subtract 30. So we have 16 plus 36 subtract 22 subtract 30, which is equal to 0. Because f of 2 is equal to 0, we can therefore conclude x subtract 2 is a factor of f of x. Part B. Hence, factorise fully 2x cubed plus 9x squared subtract 11x subtract 30. We have the cubic 2x cubed plus 9x squared subtract 11x subtract 30. And we know that x subtract 2 is a factor of this cubic. Hence, we have x subtract 2, a linear factor, multiplied by some quadratic factor ax squared plus bx plus c, which is equivalent to the cubic 2x cubed plus 9x squared subtract 11x subtract 30. To find out what a, b and c are, we can compare coefficients. So, if we consider the x cubes, on the left hand side, x multiplied by ax squared gives us an x cubed term, so the coefficient of x cubed is a, and on the right hand side, the coefficient of x cubed is 2, so a is equal to 2. Let's now take a look at the x squareds. X multiplied by bx gives us an x squared term, and negative 2 multiplied by ax squared gives us an x squared term. So the coefficient of x squared will be b subtract 2a on the left hand side, and on the right hand side the coefficient of x squared is 9. b subtract 2a is equal to 9, and knowing that a is equal to 2, we have b subtract 2 multiplied by 2, which is equal to 9, and therefore b is equal to 13. Let's now compare the numbers. On the left hand side, we have negative 2 multiplied by c, which is negative 2c, and on the right hand side, we have negative 30. Negative 2c is equal to negative 30, meaning c is equal to 15. Hence, 2x cubed plus 9x squared subtract 11x subtract 30 will be equivalent to x subtract 2 multiplied by 2x squared plus 13x plus 15. Now, we can factorise 2x squared plus 13x plus 15 even further. So, we have 2x cubed plus 9x squared subtract 11x subtract 30 being equivalent to x subtract 2 multiplied by 2x plus 3 multiplied by x plus 5. Hence, here is our result. Question number 2. The graph of y equals x cubed plus 2x squared subtract 13x subtract 4 is drawn on the grid for x being greater than or equal to negative 5 but less than or equal to 4. That is shown here. By drawing a suitable straight line on the grid, find estimates for the solutions of the equation x cubed plus 2x squared subtract 11x subtract 2 equals 0. To begin with, we have x cubed plus 2x squared subtract 11x subtract 2. And we also have x cubed plus 2x squared subtract 13x subtract 4. And to make these two equal, on the left hand side we would have to add on 2x subtract 8. Of course, x cubed remains on both sides, 2x squared remains on both sides, negative 13x plus 2x gives us negative 11x, and negative 4 subtract 8 gives us negative 12. So, instead of us having x cubed plus 2x squared subtract 11x subtract 12 equaling 0, we can write x cubed plus 2x squared subtract 13x subtract 4 plus 2x subtract 8 equaling 0. These are the same equations. Now, the graph of x cubed plus 2x squared subtract 13x subtract 4 has already been drawn on the grid. And what we can do is rearrange this equation to say that x cubed plus 2x squared subtract 11x subtract 12 is equal to 8 subtract 2x, and so we will draw the straight line 8 subtract 2x. Now, if we were to draw the line y equals 8 subtract 2x, we have a y-intercept at 0, 8, and an x-intercept at 4, 0. So let's draw that straight line. Here is the line y equals 8 subtract 2x. The y-intercept is at 8, the x-intercept is at 4. Now, where the graph y equals x cubed plus 2x squared subtract 13x subtract 4 intersects the line y equals 8 subtract 2x is here, here, and here. So what we need to do is solve for x. We have one solution here, that's x equals minus 4. We have another solution here, that's x equals minus 1. And we have another solution here, that's at x equals 3. Here are our solutions. Question number 3, part A. Solve 7w subtract 9 is less than or equal to negative 23. Give your answer using set notation. To begin with, we have 7w subtract 9 being less than or equal to negative 23. If we add 9 to both sides, we end up with 7w being less than or equal to negative 14, and dividing both sides by 7, we end up with w is less than or equal to negative 2. Hence, in set notation, we have w belonging to a set of real numbers where w is less than or equal to negative 2. Part B. On the limit line, represent t belonging to a set of real numbers where t is less than or equal to negative 1 or t is greater than 3. Well, if t is less than or equal to negative 1, that's represented here. Notice, because we have a weak inequality symbol, we shade in the circle, and where t is greater than 0, that's represented here. Because we have a strong inequality symbol, we have an empty blank circle. Part C. On the grid, show by shading the region defined by the inequalities 2y subtract 5x is less than 10 and y is greater than 3x multiplied by x subtract 2. Label this region R. Here we have the curve y equals 3x multiplied by x subtract 2. Here we have the straight line 2y subtract 5x equals 10, and the region R which satisfies both the inequalities 2y subtract 5x is less than 10 and y is greater than 3x multiplied by x subtract 2 is the green region labelled R, shown here. Part D. Write down all the integer pairs in the form xy that satisfy 2y subtract 5x is less than 10 and y is greater than 3x multiplied by x subtract 2 and x is greater than 2.5. Here is the line x equals 2.5. Where we have integer values, that will be along the line x equals 3. We have one of those points here, which is 310. We have another point here, which is 311. And we have another point here, which is 312. Hence, the integer pairs that satisfy these inequalities are 310, 311, and 312. Question number 4. The vector A is equal to 4, negative 7. The vector B is equal to negative 3, negative 2. Given that 4 multiplied by the vector A subtract 2 multiplied by the vector C is equal to 5 multiplied by the vector B, part A, find C as a column vector. If we substitute in the vectors A and B into this equation, we have 4 multiplied by 4, negative 7, subtract 2c equals 5 multiplied by the vector negative 3, negative 2. If we now expand the brackets on the left hand side, 4 multiplied by 4 is 16, 4 multiplied by negative 7 is negative 28. Then we subtract 2c, and on the right hand side, 5 multiplied by negative 3 is negative 15, 5 multiplied by negative 2 is negative 10. Hence, we have 16, negative 28, subtract 2c equals negative 15, negative 10. Therefore, 2 multiplied by the vector c is equal to 16, negative 28, subtract negative 15, negative 10. And if we work this out, 16 subtract negative 15, that's 31. Negative 28 subtract negative 10, that's negative 18. So 2 times the vector c is equal to 31, negative 18. And therefore, to find the vector c, we have to divide this by 2. Hence, the vector c is equal to 15.5, negative 9. Relative to a fixed origin O, the point D has position vector 7, 2. The point E has position vector 2y. Given that the magnitude of the vector DE is equal to 13, part B, find the possible values of y. Let's begin by finding the vector DE. The vector DE is equal to the vector OE subtract OD. Hence, we have 2y subtract 7, 2. And if we work out what this is equal to, 2 subtract 7, that's negative 5. Y subtract 2 is just y subtract 2. Therefore, the vector DE is equal to negative 5, y subtract 2. Hence, the magnitude of the vector dE, that's given by the square root of -5 squared plus y subtract 2 squared. We know that the magnitude of the vector dE is equal to 13, hence we have the square root of -5 squared plus y subtract 2 squared equals 13. And if we square both sides, we have -5 squared plus y subtract 2 squared equals 13 squared. And if we rearrange, we have y subtract 2 squared equals, now here, 13 squared subtract -5 squared, that's 144. So we have y subtract 2 squared equals 144, and therefore, solving for y is equal to 2 plus minus 12. So, y is equal to 2 subtract 12, which is -10, and 2 plus 12, which is 14. So the possible values of y are -10, 14. Question number 5. We have a set of numbers from 1 to 14 inclusive. Q are factors of 24, R are multiples of 3, S are odd numbers. For the first part of part A, explain why 3 belongs to a set where we have Q and S. So Q and S is an odd factor of 24. And of course, 3 is a factor of 24 because 3 times by 8 is 24, and 3 is also an odd number. So the reason why 3 belongs to the set Q and S is because 3 is an odd factor of 24. For the second part of part A, list the elements of the set, not S and R. So, those which do not belong to S, meaning those which are even numbers, we have 2, 4, 6, 8, 10, 12, 14, and R are the multiples of 3. Which ones are the multiples of 3? That will be the 6, and that will also be the 12. Hence we have 6 and 12. For the third part of part A, find the number of S's. This refers to the number of odd numbers we have. 1, 3, 5, 7, 9, 11, and 13 are odd numbers. How many odd numbers do we have in this set? Well, we have 7 of them. So we have 7. A number is chosen at random from the universal set. For the first part of part B, work out the probability that this number is in the set R or S. Well, in total we have 14 numbers, so our fraction will be out of 14. And we need to consider R or S. So we have R, the multiples of 3, so that's 3, 6, 9, 12, or odd numbers. So we've got 1, the 3 has already been chosen. We've got the 5, we've got the 7, 9 has already been chosen. We've got the 11, and we've got the 13. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of those numbers. Hence, the probability that this number is in the set R or S is 9 over 14. Given that the number chosen is an odd number, for the second part of part B, work out the probability that this number is in the set not Q. Well, we know from the third part of part A, we have 7 odd numbers, so our fraction will be out of 7. We know 1, 3, 5, 7, 9, 11, 13 are all odd numbers. Which one of these are factors of 24? Well, 1 is a factor of 24, 3 is also a factor of 24, meaning those which are not factors of 24 given these odd numbers is the 5, the 7, the 9, the 11 and the 13. Hence we have 5 over 7. Question number 6. The diagram shows a sector OABC of a circle with center O and radius 8 cm. AC is a chord of the circle. The area of the triangle OAC is 16√3 centimeters squared. We have to work out the area of the shaded segment that's shown here. Give your answer in the form A multiplied by B pi subtract C√3 over D centimeters squared, where A is an integer and B, C and D are prime numbers. What we can do is consider how we work out the area of the triangle OAC. For this we need 2 adjacent sides and the angle in between. So we have OC, which is 8 centimeters, which is also equal to OA, and the angle in between those, AOC, is shown here. Hence, the area of the triangle OAC is given by 1/2 multiplied by 8 squared multiplied by the sine of AOC, and we know that the area is equal to 16√3. So 8 squared is 64 and half of that is 32, and 16 divided by 32 is 1/2, and I multiply that by √3, meaning the sine of AOC is equal to √3 over 2, from which we can find AOC, and that's 60 degrees. So we have 60 degrees. We can now find out the area of the sector OABC. The area of OABC is equal to 60 divided by 360 multiplied by pi multiplied by 8 squared, which is equal to 32 pi over 3. Therefore, the shaded area is equal to 32 pi over 3 subtract 16√3. Now, if I factorize out a 16 over 3, inside the bracket we would have 2 pi, because 16 multiplied by 2 pi divided by 3 is 32 pi over 3, subtract 3√3, because 16 multiplied by negative 3√3 over 3 is negative 16√3. And here you will find 16 is an integer, the 2 and the 3 are prime numbers. We found the shaded area in the required form. The shaded area is equal to 16 multiplied by 2 pi subtract 3√3 all over 3. Question number 7. 80 multiplied by √8 to the power of 8x plus 2 over 20 multiplied by 16 to the power of 2x subtract 5 equals 2 to the power of y. We have to express y in terms of x. Give your answer in its simplest form. So we have 80 multiplied by √8 to the power of 8x plus 2 over 20 multiplied by 16 to the power of 2x subtract 5, which is equal to 2 to the power of y. 80 divided by 20, that's 4. So we have 4 multiplied by Now here, root 8, that's the same as 2 root 2. So we have 2 root 2 to the power of 8x plus 2. And on the bottom, 16, that's the same as 2 to the power of 4. So we have 2 to the power of 4 to the power of 2x subtract 5. And this is equal to 2 to the power of y. So the 4 we can rewrite as 2 squared. So we have 2 squared multiplied by, and 2 root 2 is the same as 2 to the power of 3 over 2. And this is raised to the power of 8x plus 2. And we divide this by 2 to the power of 4 to the power of 2x subtract 5, which is the same as 2 to the power of 4 multiplied by 2x subtract 5. And this is equal to 2 to the power of y. So we have 2 squared multiplied by, now here 2 to the power of 3 over 2 to the power of 8x plus 2. That's the same as 2 to the power of 3 over 2 multiplied by 8x plus 2. And then we divide this by 2 to the power of 4 lots of 2x subtract 5. And this is equal to 2 to the power of y. So we have 2 squared multiplied by, and here we have 2 to the power of, well, 3 over 2 multiplied by 8x, that's 12x, and 3 over 2 multiplied by 2, that's 3. And then we divide this by, well, here we have 2 to the power of, well, 4 times by 2x, that's 8x. 4 multiplied by negative 5, that's negative 20. And this is equal to 2 to the power of y. So we have 2 to the power of 12x plus 3. And because we're multiplying this by 2 to the power of 2, we have the same base and we are multiplying, so we add the powers. So we add on this 2. And on the bottom we have 2 to the power of 8x subtract 20. And this is equal to 2 to the power of y. When we have the same base, we subtract the powers. But first, let's simplify the 12x plus 3 plus 2. So here we have 2 to the power of 12x plus 5. On the bottom we have 2 to the power of 8x subtract 20. And this is equal to 2 to the power of y. Now subtracting the powers, we have 2 to the power of 12x plus 5 subtract 8x subtract 20 equals 2 to the power of y. So we have 2 to the power of, now here, 12x subtract 8x, that's 4x, and 5 subtract negative 20, that's 25. Hence we have 2 to the power of 4x plus 25 equals 2 to the power of y. And now if we compare the powers, we see that y is equal to 4x plus 25. Question number 8, part A. Write 3 subtract root 5 all squared in the form c subtract d multiplied by root 5, where c and d are integers. So 3 subtract root 5 all squared is the same as 3 subtract root 5 multiplied by 3 subtract root 5. So 3 times by 3, that's 9. 3 multiplied by negative root 5 plus negative root 5 multiplied by 3, that's negative 6 root 5. And negative root 5 multiplied by negative root 5, that's positive 5. 9 plus 5, that's 14. So we have 14 subtract 6 root 5, which is our answer. Part B. Show that 4 plus 3 root 5 over 3 subtract root 5 squared plus root 20 can be written in the form e plus root 5 over f, where e and f are integers. To begin with, we can use the result that we found in part 8. 3 subtract root 5 all squared is 14 subtract 6 root 5. So we have 4 plus 3 root 5 over 14 subtract 6 root 5 plus root 20. Let's now manipulate this. We have 4 plus 3 root 5 over 14 subtract 6 root 5 plus root 20, and root 20 we can write as root 4 multiplied by root 5. So we have 4 plus 3 root 5 over 14 subtract 6 root 5 plus, now here, root 4 multiplied by root 5, that's just 2 root 5. Let's simplify this. We have 4 plus 3 root 5, and here 14 subtract 6 root 5 plus 2 root 5, that's 14 subtract 4 root 5. We have 4 plus 3 root 5 over 14 subtract 4 root 5. And effectively, we need to multiply this by 1. But when we multiply by 1, we need to multiply both the numerator and the denominator by the conjugate of the denominator. In other words, we multiply this by 14 plus 4 root 5 over 14 plus 4 root 5. Effectively, this is 1. So, 4 times by 14, that's 56. Then we have 4 times by 4 root 5, that's 16 root 5. Then we have 3 root 5 multiplied by 14, which is 42 root 5. And then we have 3 root 5 multiplied by 4 root 5. Well, the 3 times by the 4 is 12, and root 5 multiplied by root 5 is just 5. So we add on 12 times by 5. And for the denominator, we have a difference of 2 squares. 14 times 14, that's 196. And we subtract from this 4 root 5 multiplied by 4 root 5. 4 times 4 is 16. Root 5 times root 5 is 5. So we subtract 16 times 5. Let's simplify as much as we can. We have 56 plus 16 root 5 plus 42 root 5, and 12 times by 5, that's 60. So we add on 60. And for the denominator, we have 196, subtract 16 times by 5, which is 80. And now if we simplify even further, 56 plus 60, that's 116. 16 root 5 plus 42 root 5, that's 58 root 5. And then we divide this by 196 subtract 80, which is 116. 116 over 116, that's just 1. And we add on to this 56 root 5 over 16, which is just root 5 over 2. Hence, we end up with 1 plus root 5 over 2. Question number 9. The line y equals 3mx subtract 2 is a tangent to the curve y equals 4x squared plus 2x plus 7. Find the possible values of m. If this straight line is a tangent to this curve, that means the line intersects the curve once, and so we can set those equations equal to each other. So we have 3mx subtract 2 equals 4x squared plus 2x plus 7. And if we rearrange, we end up with 4x squared plus 2 subtract 3mx plus 9 equals 0. Now, if we know we have a tangent, we can use the discriminant, but for that we need the values of a, b and c. A is 4, b is 2 subtract 3m, and c is 9. Hence, using the discriminant, we have b squared minus 4ac equals 0. So we have b, which is 2 subtract 3m squared, subtract 4 multiplied by a, which is 4, multiplied by c, which is 9, and this is equal to 0 because this line is a tangent to this curve. Now, expanding 2 subtract 3m all squared, we end up with 4 subtract 12m plus 9m squared, and then we subtract from this 4 times 4 times 9, which is 144, and all this is equal to 0. So we have 9m squared, subtract 12m. Now 4 subtract 144 is negative 140. So we have 9m squared subtract 12m subtract 140 equals 0. If I factorize the left hand side, we end up with 3m plus 10 multiplied by 3m subtract 14, and this is equal to 0. Meaning, if I solve for m, if 3m plus 10 is equal to 0, that means m is equal to negative 10 over 3. And if I solve 3m subtract 14 equal to 0, we end up with m equals 14 over 3. So m is negative 10 over 3 of 14 over 3. Question number 10. Circle C has equation x squared subtract 2x plus y squared subtract 14y plus 25 equals 0. The point A with coordinates 4, 11 lies on C. Line L1 is the tangent to C at A. Line L2 has a positive gradient and passes through A. The area of the triangle enclosed by L1, L2 and the x-axis is 110. We have to find an equation for L2. Let's begin with the equation x squared subtract 2x plus y squared subtract 14y plus 25 equals 0. And let's write this in the form x subtract a squared plus y subtract b squared equals r squared. If I complete the square for the x's, I have x subtract 1 squared subtract the square of 1. And if I complete the square for the y's, we have y subtract 7 squared, and then I subtract the square of 7, and then I add on the 25, and this is equal to 0. Simplifying, we have x subtract 1 squared plus y subtract 7 squared equals 25. In other words, x subtract 1 squared plus y subtract 7 squared equals 5 squared, meaning the centre has coordinates 1, 7, and the radius is 5. Now, here is a diagram representing the circle C. We've got the line L1, which is a tangent to C at the point 4, 11. We've got the centre of the circle at 1, 7. And we've got some line L2, which also passes through 4, 11. And what we can do is find the equation of L1 to begin with. For us to find the equation of L1, we first of all need the gradient of the radius and recognize that the radius and the tangent are perpendicular to each other. So the gradient of the radius, that's equal to 11 subtract 7 over 4 subtract 1. And if I work this out, I get 4 over 3. Meaning the gradient of the tangent of L1 is equal to the negative reciprocal of 4/3, which is negative 3 over 4. And knowing that L1 passes through 4, 11, we can therefore state that L1 has equation y subtract 11 equals negative 3 over 4 multiplied by x subtract 4. And if I expand the brackets and simplify, we have y equals negative 3/4 x plus 14. We know the equation of L1 and we know the area of this triangle. Now, I can find out what this point is by finding the x coordinate when y is equal to 0 of equation L1. I know the height of the triangle, and if I somehow find out what this point is, I can find the gradient of L2 and then the equation of L2. So let's begin by finding where L1 intercepts the x-axis. We can do that by setting y equal to 0. So we have negative 3/4 plus 14 equals 0, meaning x is equal to 56 over 3. So this point is 56, 0. For me to find the equation of L2, I need 2 points that pass through L2 to find the gradient of L2. Now, I know that I've got a triangle here with area 110 square units. I can find out the height, that's quite simply 11. I can also find out where L1 intercepts the x-axis by setting equation L1 equal to 0. And if I know this point, I know the height, I can find this point using the area of the triangle. So if I set y equal to 0, we have negative 3/4 x plus 14 equals 0, meaning x is equal to 56/3. So here I've got 56/3, 0. I've got the height of the triangle, which is 11 units, and now I can use the fact that the area of the triangle is 110, the height, and this point to find out what this point is. If this point has an x-coordinate of xl2, then the area of the triangle is given by a half times 11 times 56/3 subtract xl2, and this is equal to 110. And if I solve for x, you'll find x to equal negative 4/3. Meaning, this point has coordinates negative 4/3, 0. Now that I know what this point is, and I know that L2 also passes through 411, I can find the gradient of L2 and then state the equation of L2. So, the gradient of L2 is equal to 11 subtract 0 over 4 subtract negative 4/3, which is 33/16. So L2 has equation y subtract 11 equals 33/16 multiplied by x subtract 4, which simplifies to y equals 33/16x plus 11/4. Question number 11. If m and n are integers where m doesn't equal n, then m plus n is greater than m. Disprove this statement by means of a counterexample. Well, if m is equal to 1 and n is equal to 2, then m plus n, we would have 1 plus negative 2, and that's equal to negative 1. And if I compare that with what m is, remember m is 1, we see that this is less than 1. We want the result to be greater than 1, hence the statement is false.